Hello guys, welcome back. In this video I'll talk about DeepSeek OCR. I think it is very important because in my opinion it could change the way how current business model works for the data extraction with the cloud subscription and with legacy providers for the data extraction. Because DeepSeek OCR works very fast and it provides relatively good quality of the conversion from original scanned document or PDF document into the markdown format. And I'm integrating now DeepSeek OCR into Sparrow to get the markdown format, and then I'm using text-based LLM to analyze and process this text based markdown structure to get meaningful relationships between data fields, between keys and value pairs, and this would help to improve performance and accuracy for the large table processing for the data extraction from the large tables. So let's see using 4 examples how DeepSeek OCR works. So the first one is bonds table, and I'm using DeepSeek on my local machine on Mac Mini M4 Pro with 64 gigabytes of memory, which is shared with M4 GPU. And running Ollama on this machine, and I'm using DeepSeek through Ollama. It's very convenient and it works stable and very well. So running now request to process this bonds table, and you see it's extremely fast. We got back the data in a markdown format. Now I could go and copy this table, not table, but the document. I could copy it into this empty markdown file, and I could check how it looks like. It in more readable way how the data was extracted. So we got here header information, and here we get table. So we get instrument names are correctly fetched, and then if you check, for example, last row, we get here 17.5, then percentage, then 23,643, and 4.53%. So this is exactly like it is in the document. And very important thing that DeepSeek OCR doesn't invent or hallucinate. It gets you exactly data as it is in the document. For example, without missing any elements, like here we would have 19 and this comma on the top 049, exactly the same as it is in the document, which is not the case typically with Vision LLM, because Vision LLM tends to interpret the data and it may return slightly different numbers, slightly different formatting for the numbers than it is in actual document. Okay, so this is for the bonds table. Okay, we can remove that and let's clean it up. Then next one is invoice. I think it's over here. Yeah, this Ollama run DeepSeek OCR, and then we point to the file, and then we say that we would like to convert this document to the markdown. So we execute, and image is processed, and we get data printed as the model returns the result. So we got in a few, like in a split of the second, basically we got the result. And now let me copy paste it. Okay, got it here and paste it into the markdown file. And then let's say I want to display it this way, and we get all the data. And interesting thing that for the non-table, for the form data structure, we get values, and also beside that we get coordinates. So I believe this also will be a great hint or help in the next step for the text-based LLM when processing this markdown data, it may understand, it may actually, text-based LLM may understand this input better, because it's not only raw text, but it also comes with coordinates, and it may relate better labels and values of the related fields. Okay, then we got table here, which is very well structured, and all the data is correct. And then we get summary table, small table, which also comes correct. Okay, so this is really impressive, I think. And now, if you go to another example of this financial statement, I think it's located over here. Yeah, this points to the Olama run DeepSeek command points to the Oracle financial statement, and we give the instruction to convert the document to the markdown. Okay, this is slightly longer document, but still it's processed very fast, and we got back the result again in a second or 2 seconds, so which is extremely fast. On Vision LLM on the same machine, it would take around from 60 to 90 seconds to process this kind of document. So in terms of the performance improvement, there's basically huge improvement, and it's even not comparable to the Vision LLM in terms of the speed. Okay, so we got back, we copied the produced markdown structure, and we can see in this case it's not 100% correct in terms of the structure. We got here descriptions, fine, but then we get under assets, we get first value, but it should be under August, and so it's slightly messing up with table structure in this case. But if we scroll down and check over here, the actual values are correct. So the structure is a bit messed up, but values are fine. And I think still this is a great result, because it's more complex document. And as soon as we'll pass even this slightly incorrect structure into the text-based LLM, I think LLM would be able to process the structure and return correct data relationships. Because for the text-based LLM to handle this task with text data, it's easier, based on my experience, than for the Vision LLM to process from the start entire image with the document. Okay, and now we remove this text, and finally the last test with the bank statement. So we go to this tab, and yeah, this points to the bank statement, and we execute command. And like in my previous videos, I was explaining Vision LLM often would struggle with the sparse tables when some of the values are missing, like there is no value for the withdrawal, then there's no for the deposit, no for withdrawal again, and so on. And then Vision LLM may start to hallucinate, and it may assign correct fetch values into the wrong positions, into the wrong columns, like withdrawal value could be returned for the deposit, and so on. And with DeepSeek OCR, this doesn't happen based on my tests, and it works much more predictable in this sense. Okay, so let's copy the data into markdown file, and let's view it. So we'll skip form data, let's look in a table, and we see this is correct. There's 25 for the deposit, then the value under the withdrawal, then deposit, then withdrawal, deposit, and 2 values for the withdrawal and 2 values for the deposit. So which is 100% correct, and it was very fast and very accurate, which would be a challenge for the vision-based LLM, even for the quite good LLMs like Mistral, it would produce correct result, but it would be slower. Around for the same document on my machine, it would be around probably 80 seconds. Like in this case, we had like probably maximum 2 seconds, so it's way faster. So thanks for watching, and stay tuned. Keep track about Sparrow development and improvement. I'm busy improving Sparrow, adding new functionality, and making Sparrow useful for your practical use cases. So thanks for watching, and see you next time. Bye.